If you've ever tried talking to someone in a crowded room, you know how fragile hearing really is. A little background noise, and suddenly, words fall apart. But for millions of people, it's not noise that's the problem. It's that the pathway for sound doesn't exist at all. Normally, hearing starts as vibrations in the air. These vibrations make up words and sounds. So, how do we hear? Those vibrations enter the ear and then move the eardrum, where they get converted into electrical signals. Those signals travel through the auditory nerve to the brain's temporal lobe, where sound is actually perceived. This pathway is essential. When the auditory nerve is damaged or absent, there's no route left to send sound to the brain. In those cases, there is currently no restorative hearing technology available. Cochlear implants amplify sound, but this isn't a volume problem. It's a pathway problem. That's where my research begins. Rather than fix the ear, it asks a different question. What if we skip the ear? My project, called tESpeech, bypasses the auditory system entirely. I built a computational framework that converts spoken language into patterns of electrical stimulation. The brain interprets this using a technique called transcranial electrical stimulation, also known as TES. To do this, we use Praat, a phonetic analysis tool to extract the precise timing and structure of the phonemes, which are the smallest building blocks of sound. Let's talk about the blocks. For example, the words bat and cat. If you take a sound pattern like b, and t and change just one phoneme to k, the structure stays the same, but the meaning changes entirely. This is why my system encodes structure and timing, not words or vocabulary. Since every spoken language is built from phonemes, my approach is linguistically universal. Let's get into the mechanics. The phonemes, our blocks, are mapped to electrical patterns that can be delivered directly to the brain's auditory regions. In other words, it turns sound into electricity the brain can understand. This matters because millions of people with complete auditory nerve loss are currently excluded from all restorative hearing technologies. But this approach suggests a different possibility, that hearing isn't defined by ears at all, but by the brain's ability to interpret patterns, no matter how they arrive. So, can we hear without ears? Not yet. But for the first time, it might actually be possible.